All right, let's talk about something that sounds, well, kind of basic, but is actually one of the most powerful secrets in your entire machine learning toolkit. I'm talking about Python data types. And no, this isn't going to be some boring syntax lecture. This is about the one thing that makes the difference between a model that works and one that doesn't. So let's kick things off with a question I'm pretty sure we've all screamed at our computers at some point. You know the feeling, right? You've got this incredible model architecture, you found the perfect data set, you hit run, you're feeling good, and then, bam, it all just falls apart with some error message that makes zero sense. So why? Why do these super powerful, super complex models just fail? Well, a lot of the time, the answer is hiding in plain sight. It's not some huge, fatal flaw in your logic. It's usually something tiny. You know, a number that's accidentally being treated as text, or a list of features that should have been locked in place. It's almost always the wrong data type. Okay, so if that's the problem, then the solution is getting back to basics. We've got to understand our building materials. Before we can even dream of building a fancy model, we need to pour the foundation. We have to get why these data types are so important.
This right here, this is the golden rule of Python. You got to burn this into your brain. Everything, and I mean everything, from a simple number to a huge, complex data set is an object. And every single one of those objects has a specific identity, a label that tells Python what it is.
So what is a data type, really? Think of it like a job description for your data. It tells Python two crucial things. First, what kind of information is this thing holding? Is it a whole number? Is it text? And second, what can you actually do with it? I mean, you can add two numbers together, but you can't really divide the word hello by two, right? The data type sets the rules. And this is the part that matters most for us. Machine learning models. They are just giant, fancy math equations at their core, which means they're super picky. They don't understand words like cat or dog. They need numbers that represent cat or dog. If you don't feed them data in the exact numerical format they're expecting, they just give up. All right, now that we know why this matters, it's time to meet the crew. Let's do a quick tour of the core building blocks, the data types you're going to see and use every single day when you're working on ML projects. First up, we've got the absolute workhorses of the data world, the numerics. You've got int for integers, that's any whole number, positive, negative, doesn't matter. And then you have float for floating point numbers, which is just the programmer's way of saying a number with a decimal point. Simple as that. Now, don't let their simplicity fool you. In machine learning, int and floats are literally everything. They are the lifeblood of your models. Your features, the model's internal weights, your final predictions. It's all numbers. This is the language that every single machine learning model speaks. Next up, we have the string, or str for short. This is how Python handles any kind of text, whether it's one letter or a whole novel. Super useful for us humans, but for machine learning, it's got a big catch. And here's the catch you absolutely have to remember. Strings are perfect for things we can read, like the labels cat or dog in your dataset. But, and this is a big but, before you can train a model on that data, you must convert those words into numbers. That process is called encoding, and trust me, it is a non-negotiable step. Okay, what if you need to store a bunch of things together? Well, you've got two main options, lists and tuples. They look almost the same, but there's one massive game-changing difference between them. A list is mutable. You can change it, add to it, remove stuff from it. A tuple, on the other hand, is immutable. Once you create it, it's set in stone. So how do you decide which one to use? It all comes down to what you're trying to do. If you're grabbing a row of features from your data and you might need to clean it up or change a value later, a list is your best friend. But if you have data that should never, ever change, like the dimensions of an image, its height, width, and color channels, you use a tuple. It's safer. Now for my personal favorite for keeping things organized, the dictionary, or dict. Instead of just a sequence of items, a dictionary stores data in pairs, a key and a value. It's like giving every piece of your data its own little name tag, which makes looking things up incredibly fast and easy. And in machine learning, this structure is a total game changer. Need to keep track of your model's settings, like the learning rate or a batch size? A dictionary is perfect for that. And remember how we needed to turn cat into a number? A dictionary is the ideal tool for creating that map, to explicitly say cat is 0 and dog is 1. Okay, so we've met the building blocks, but knowing what they are is just half the story. we've got to put this stuff into practice. So how do we actually take messy, real-world data and get it into the perfect numerical shape our models need? So you've loaded your data, but you're looking at it and you're not totally sure what Python thinks it is. Before you do anything else, you have to be able to answer two simple questions. What type of data is this, and is it the right type? Luckily, Python gives us two super simple, super powerful skills for this. The first is type checking. Think of this as asking a question. You use something like isInstance to ask Python, hey, is this variable an integer? The second is typecasting. This is where you give a command. You use functions like int or float to tell Python, hey, turn this variable into an integer now. And here's a classic example. This happens all the time. You load data from a CSV file, and your numbers get read in as strings. So your model doesn't see the number 42, it sees the text 42. All you have to do is run one simple line of code, x equals into x, and boom, you cast it to the right type. Just like that, your data is fixed and ready for your model. Okay, let's zoom out for a second and look at the big picture. All these little functions and types, they're not just random commands to memorize. They are your master key for machine learning. Really understanding this stuff is what separates the pros from the amateurs. Let's see how it all fits together. Think of this table as your ultimate cheat sheet. It connects everything we just talked about. See the pattern? You've got integers for IDs and counts. You've got floats for the actual measurements and feature values. Strings are for those human-readable labels that you're going to convert later. You use a list to gather up all your features for one sample, a tuple to lock down things like an image shape, and a dictionary to organize your settings. This is the playbook, right here. And that's really what it all comes down to. Getting good at this isn't just about writing code that doesn't crash. It's about being deliberate. It's about knowing your data so well that you can perfectly sculpt it into the exact shape your model needs to learn. That is the difference between a model that fails and a model that truly works. So from now on, don't think of data types as a chore or some boring prerequisite. Think of them as the keys to a car. They unlock the real power hidden inside your data. The only question left is, now that you have the keys, what are you going to build?